Right then, so I am going to need to remind you of vector straight lines from earlier in the year. I'm going to grab a black pen just stand up to the camera a bit more. Right, so I'm going to give you 2 points. Can you please tell me the vector straight line that connects them? So A is 2, 3, negative 1. B is 0, 1, negative 3. So can you tell me the vector straight line AB that passes through both points? Again, if you've been revising at all, this is one of the first things you'd have done, because I told you to do vectors, series, and what was the other one? Vieta. So what is the equation of the vector straight line that passes through both of them? Okay, so this shouldn't be a terribly difficult thing. So if we imagine we've got point A and we've got point B, so I am looking for the vector straight line that passes through both of them. So specifically the equation of the line that passes through A and B, so any point on this line. So what is the vector that gets me from A to B? So to get from A to B, do you agree I need to go down, left by 2, down by 2, and you can find your i's, j's, and k's. So this is negative 2i, negative j, negative 2k. Okay, great. Where's my starting point? Do you want to do A or B? I don't mind. Yeah, A is usually the logical one. So starting at A, so vector AB. So I'm going to point this out as well, because I mentioned, I need to mention this because I noticed it in the marking scheme when I was marking some of you actually lose a mark if you don't write R equals in certain ones. So the way to write it is AB and then R equals, or it's CD. And is it stupid saying that they're both R? Yeah, they are. But it's what it is. So R equals, and so it's position A. So A is at this position. And then it's some constant times by these. Okay, so let's talk about why this is what it is, right? So, do you agree the idea is you should be able to get to any point on this line by putting in the appropriate value of lambda, right? So you start here, and you agree this vector movement will move you one jump this way. So you can get any point on this line by starting here and doing jumps of this. So say I wanted to go to here, do you agree it would be 2/3 of a jump? So I do start here, and I do 2/3 of this jump. So you just change your lambda depending on what it is. So, if I've got a particle P is at 2, negative 1, 3, and it moving with velocity 3I minus k. So essentially, a particle is at this position at the moment, and then it moves with that velocity. So am I mentioning this stuff about vector straight lines for no reason? Is there obviously a thing we can do here to kind of model this particle's path? So do we agree that it starts here at, so if you do R for P, R equals 2I minus j plus 3k. So do we agree it starts there? And what's the idea of this velocity vector? So what does a velocity of 3I minus k actually mean? It means for every second, it's going 3 meters to the right and 1 down every second. That's what it means. So you agree that we would times by lambda 3I minus k effectively, and now this would model the position of the particle. But what is lambda in this instance? Because there's something better, you can call it something better than lambda. What is lambda really? You agree it starts here at time 0, and then every second it adds one of these. So what is lambda really? It's time, right? Yeah, it's the amount of time that's passed. So, for example, after 3 seconds, you agree it started here, and it's moved 3 of these. So t would be 3, and so on. Yeah. So essentially you use a vector straight line to model a path. Okay, so the way that this will be done is 2 aeroplanes or 2 drones will have a vector straight line equation. So A is currently at 2, 5, and B is currently at 3, negative 1, and it's moving at I plus j, and this one is moving at, and I have to be careful how I do this, so, and it's moving at 7I plus j. Okay, so essentially these 2 planes, can we model their paths with vector straight lines? Yeah, effectively we can. So A would be r equaling 2I plus 5j plus t times by I plus j. And then B would be r equaling 3I minus j plus, and when we do a vector straight line normally, do you know how you normally use lambda and I would use mu, right? So in the context we're using, I would actually use the same constant, y. Because degree time passes the same for both objects, right? So in a sense, they're actually the same constant. It actually makes it quite a lot nicer. Okay, so my question now is, do these 2 planes ever collide? Is there a time where they're occupying the same space? So what we do is we put them in their component form. So this is I, degree I would be 2 plus t, then j would be 5 plus t. And then in this form, it would be I times by 3 plus 7t, and then j, it would be minus 1 plus t. Okay, so from this then, how do we check if there's a time at which they collide? So what are I and j? What do they represent? Position in x, position in y, right? So for them to occupy the same space, this has to equal this, and this has to equal this, effectively. So that's how you would do it. So let's see if it works. So 2t, 2 plus t equals 3 plus 7t, and also we have that 5 plus t equals minus 1 plus t. So this one will have no solutions because I'm going to minus t on both sides, and then I'll get a 5 equaling negative 1. So that means that they will never intersect. You need both of them to have the same answer. So no, these 2 will never intersect. And I could do this one as well. So 6t equaling minus 1, t equaling minus a sixth. Why is t equaling minus a sixth absolute nonsense? Yeah, you can't have negative time. Or it's saying that they collided before they start. So they're starting here. So it's saying that they collided like further back on their straight lines effectively, which again is nonsense. Okay, but what you can do is work out the closest distance between them. So this is quite a common thing for you to see. So state an expression in terms of t for the distance between them, between A and B. Okay, so we want to find an expression in terms of t for the distance between them. So how do we attack this then? What would the distance between them be? So because they're vectors, right? So how do you find the distance between 2 vectors? You just take them away from each other, right? So what we're looking for is A minus B, effectively. But there's a problem in that as well. So degree asks for an expression. So how could we get an expression from a vector? Degree is the length of the vector. So if I draw these lines out specifically, so let's say this is A. So this is the flight path of A, and this is the flight path of B. So they don't actually ever intersect, really. So they don't really intersect ever. So this one starts here, one starts here. So what we're looking for is a formula that will tell us the distance between here and here at some point, or between here and here. So if this is A and this is B, do you agree that this is A minus B? Then do you agree that A minus B varies, right? With what time is? Do you agree that this is a length? So it's the length of the vector, effectively, is what we're looking for. So the length of A minus B squared, we'll start with. So the magnitude of the displacement between them. So let's do A minus B then. So T take away 3 is minus 1. So let's start with A minus B. So this is minus 1 minus 6t, and that's I. And then plus 6j, that's it. Okay, and that's our vector for the distance between them. And then what we do is we take its magnitude. So A minus B squared, so the magnitude squared would be 6t plus 1 squared plus 6 squared. And so the distance between them, the formula for that would be the square root of this. So it would be 36t squared plus 12t plus 1 plus 36. So this is 36t squared plus 12t plus 37. So if you want the distance between them, it would be this formula here at time t. So specifically this one, 36t squared plus 12t plus 37. Okay. So going back to my question from yesterday then, so I'm actually going to keep this as squared for now because it's more useful. Okay, so I've got my formula for the distance between them. How would I, so we've checked that they don't collide, which is fine. How would I find the time then at which they're the closest? How would I find the time that they're closest together? So think about what we did yesterday, right, when we were minimizing the distance of OP. So do you agree the distance between them is given by 36t squared plus 12t plus 37, right? So is there something we can do to find the minimum time? Like, what did we do yesterday? Because we're trying to find the minimum.
T equals 0?
Not t equals 0, no. You said, yeah, I know what you mean, but you're not saying it correctly. It's the stationary point, right? So the derivative is 0. Yeah. So the derivative of this being 0 is what we're looking for. So the derivative of A minus B squared. So this would be 72t plus 12 equaling 0. And so the time that they're closest together would be -1/6, which is, yeah, exactly what we had up here. And why does that kind of actually make sense? Because you agree the time they technically collide according to our model was -1/6. So the time they're closest together is at -1/6. But you would never actually get one like that. It would be like two vectors that are somewhat reasonable. So let me show you the sort of thing I'm referring to. So I'm going to give you the question I'm referring to. And to be honest, we are covering more like out there grounds at this point, just because I want to cover my bases. So if I go to mechanics here, I'm looking for, yeah, perfect. Okay, so the position vectors are in kilometers. There's two small aeroplanes, A and B, relative to fixed point O, are given by those vectors there, with T denotes the time in hours after 9 AM, where P and Q are constants. So the aeroplanes are on course to collide. So show that P equals 140 and Q equals 4. So can you have a go at finding P and Q, please, using this technique I did up here. So you have to do this right here. Get them in the component form and equate them. So because they're on course to collide, you should be able to get two equations from it. so I'm gonna get started with part A. So R sub A is equal to 60I plus 2J plus 4K plus T times by 168I plus 132J. And then R B is given by 62I plus 3K, and that's plus T times by 160I plus PJ plus QK. Okay, so checking each of these into component form then, so R of A is I and then 60 plus 168T, and then J2 plus 132T, and then K, and it's just 4. Yeah, it's just 4 because there's no K's in that one. And then RB, and then checking this in component form, 62 plus 160T plus 0J, and just P, and then K would be 3 plus Q times T. Yep, I think that's everything. Right, so the first equation we get is that 60 plus 168T equals 62 plus 160T, and then we get that 2 plus 132T equals P, and then we get that 4 equals 3 plus TQ. Okay, so out of these three equations, which one is very solvable? Yeah, the first one's very solvable, yeah. So this over here, so 8T, so we get that 8T equals 2. So T is 0.25, so T is a quarter. And now that I know T is a quarter, is this one quite easy to do? Yep. So now that I know T, and then I know T being a quarter, I can do this one as well. So P is equal to 1/4 of 132, so that is, oh god, 33, yeah, plus 2, so that's 35. And then this P is 140. Oh my god, what have I done wrong? So T is 0.25, it's fine.
PT, so you times by 4.
Oh, it's PT, isn't it? Yeah, thank you. Yeah, it's PT, so it's 0.25p. Yeah, thank you. So 0.25p equals 35. Yeah, so p equals 140. And then for this one, we have 1 equaling 0.25q, so q is 4. Okay, so those are our vectors, p and q are found, and the time, and the time they collide is 1/4 of an hour from when they start. Yep. Right then, so the next part, find an expression for the square of the distance between A and B. So we need to do R of A minus R of B, and go from there. So R of A minus R of B, so this would be 2, so minus 2 plus 6, sorry, plus 8t I, and then this would be, so if I write this as, as I write this as, what was P4 one then? Yeah, 4t, and this was 140t, sorry, and this was 4, wasn't it? Okay, so to go back to what I was doing, so then it's that it's this, take away 140t, so it's 2 take away 8t, and then it would be this, take away this, so 4 take away 3 minus 40, so this is j, and then it's 4 take away 3 minus 40, so 1 minus 40k. Okay, so this is our expression, this is our vector for the distance between them. So then we take the magnitude of RA, take away RB squared. So this would be 8t minus 2 squared plus 8t minus 2 squared. Oh, that's convenient. Yeah, that is really convenient actually. And then 1 minus 4t squared. So this would be 64t squared minus 32t plus 4 plus 64t squared minus 32t plus 4 plus 1 minus 8t plus 16t squared. Okay, so 60t squared is 64, 64, 16, so that is 80 plus 64, so 144, which I believe is correct. And then minus 32 minus 32 minus 8, so minus 72t. And then plus 4 plus 4 plus 1, so plus 9. Okay, and that's our expression for the distance between them squared. Right then, I've noticed in that quadratic all divides 9, so I imagine that's correct. It looks like it actually goes. Okay, both aeroplanes have systems that activate an alarm if they come within 600 meters of each other. Determine the time when the alarm is first activated. Okay, so we've got that expression for the distance between them squared. How do we use this for part C? So once again, are they asking you to do part C out of nowhere? Or is it going to involve what you've just done? It obviously involves what you've just done, right? So what we've discovered is, hang on. So what we've discovered is that the distance between them squared, so the distance between RA and RB squared is given by 144t squared minus 72t plus 9. So the alarm goes off when they come 600 meters within each other, within range of each other. How would we use what we've just done to find that time? Right, you need to talk to me here. So what does that formula give you? It's the distance between them, right? And the alarm goes off when the distance between them is 600. So what do we do? Yeah, exactly that. So the distance between them is 600. So are we happy that this is the distance squared? So you have to be careful of that. So it's 600 squared equaling this. And then we solve it. So 36, 0, 0, 0, 0. This equals 144t squared minus 72t. And then plus 9, and we just bring it over. If they come 600 meters within each. Yeah, okay. So we get 144 t squared minus 72t, and then minus 359,991. Okay, I am just going to let the calculator do this one. It's my calculator too. Okay, so we get that 144 negative 72 negative 39991. So I get it to be okay, this makes absolutely no sense. What have I done here?
Would it be first when you did a squared on the other board?
Say again, sorry?
Would it be when you did a squared on the other board, you did 8 minus, or 80 minus 2 twice, even though for J is minus 8t plus 2.
By 2? Show me what you mean?
Where you do R8 with RB squared,
Yeah.
you have the two brackets, the 8t minus 2 squared,
Mm-hmm.
for I, and then for the other one, wouldn't it be minus 8t plus 2?
No, they're the same thing. Minus 80, so minus 80 plus, so they're the same thing because you're squaring it. It's like if you square 7 take away 5, it's the same as 5 take away 7 squared. I just write it the right way around just 'cause it's tidier. No, that's correct. What have I done wrong here then? Hang on. So I've got it here anyway, so I'll just check it. So, yeah, it's fine. 144 t squared, yeah, sure. Oh, I know, yeah. I've done something really dumb. Right, so, it's actually much simpler than that. We've done the correct thing, but it's actually quite cheeky, really. So, when does the alarm go off? When they come within 600 meters of each other, right? What does it say on the very first line? R in that be in kilometers, so it's 0.6. That's the trick. Right, so 0.6 squared, so 0.36, and 144 t squared minus 72t plus 9. So we have 144 t squared minus 72t, and then plus 9 take away is 0.36, so that would be 8.64. Okay, and that equals 0. So we get t equaling from this that t is equal to 8.64 there. So we get it's equal to 0.3 or 0.2. And again, that's actually quite clever in a way. Right, so we have to reject one of these answers. Why we reject? Which one are we rejecting? So it's when the alarm goes off when they're within 600 meters of each other. So which one, based on what we did before, which one do we actually have to reject? So here's what's happening. You've got your two vector lines, right? They intersect here. This is the first time where they're at 600. This is another time where they're 600 apart. One is before the crash, one is after the crash.
0.2.
Why is it 0.2?
Because the crash happened at 0.2.
Yes, exactly that, yeah. So this one we reject, and this one we accept. And then there's a bit, unfortunately, it does ask for the time as well. So what's 1/5 of an hour? So that's a fifth, right? So what's 1/5 of an hour? It's 12 minutes, right? So the crash occurs at 9:12 a.m. Right, I'm going to give you one to try yourselves again. So let's do right here somewhere. Yeah. So this is from the last year's paper. We are just going to do it one bit at a time, okay? So for 3 marks, can you please just do this first bit? So at time t equals 0, a drone has position vector of that and is flying at a constant velocity given. And then drone B gives you a similar sort of thing. Write down the position vectors of A and B at time t. Okay, so the position vector is given at the start for A as r equaling 3I minus 10j plus 20k, and then every second it moves with minus I plus 2j plus k, and then B, r is given by minus 2I plus 30j plus 15k, and it's flying with a constant velocity of this, so constant velocity being 3I minus 4j plus 2k. And yeah, are we happy with those raw vectors? Easy enough. Okay, and given that AB is the distance between A and B at time t seconds, show that AB squared is equal to 53t squared minus 530t plus 1650. So if you finish, the next part is asking to find what distance are they the closest together. So what's the closest distance they are together? Alright then, so the distance between A and B, that vector, would be, so 3 take away minus 2 is 5i, minus 10 take away 30 is minus 40. J, 20 take away 15 is 5k, and then plus t times by minus 1, minus 3, so minus 4i, 2 take away 4, so plus 6, 1 take away 2, so minus 1, and then we need to take the magnitude of this, so I write this as I, and then 5 minus 40 plus j, minus 40 plus 6t plus k times by 5 minus t. Yep, okay, great. And then, so the magnitude of a minus b squared, so ab, the length ab squared would be 40 minus 5 squared plus 6t minus 40 squared plus t minus 5 squared. Okay, so 16t squared minus 40t plus 25 plus 36t squared minus 480t plus 1600 plus t squared minus 10t plus 25. Okay, so this is 16, 36 and 1, so that's 16 and 36, that's 52 plus 1 is 53t squared. And then we've got minus 40 minus 480 minus 10. So 480 plus 50, that's 530, but negative, so minus 530t. And then 25, it must be another number, yeah, there must be. Well, 25, 25 and 1,600, so it's 1,650. And is that what they wanted? Yes, exactly that, perfect. Okay, and now part, we'll be able to get to that, okay? Yeah. This part C then. Determine the value of t when A and B are closest together, hence find the least distance. So I'll do this because I want to have a go one more before we leave. So we're going to find the minimum of this. So the derivative of AB squared is going to be 106t minus 530. So do we agree that this is a stationary point, so at A equals 0, so t equals 5? Yeah, 530, but 106 goes into 530 that many times. So t equals 5, so at 5 seconds in, that's when they're closest together. And how do we find the distance at that point? Yeah, set it back in, yeah, exactly, that's the y value. So AB squared equals 53 times by 5 squared minus 530 times 5, 1,650. $325. So AB squared is equal to 325 meters. So AB is the square root of 325, which is literally, so for those who don't know, 18 squared is 324, which is basically 18, it'll be 18 in a bit, so it's 18 meters. Yeah, they're 18 meters apart, and that's the closest they get. Right, I want to do one more before we go, which uses a bit of that, but not loads. So, I put the worksheets in the Google Classroom on this. So let me show you. So, with regards to vectors, I'm expecting 2 questions on vectors in your exam. I'm expecting ones like the one we did yesterday, and I'm expecting one like this. There's also another type of vector question that could come up. We're going to cover that on Friday. So, all these here, this vector calculus homework that I made last year, this is extensive. This covers every single type of vector question. This is a very long homework. I think I was watching Lord of the Rings when I wrote this. So, yeah, it's quite long, to say the least. Yeah, there's 14 questions, and it ends with ones like this that we've just done. And also you need to work with ones like this, which is what we'll do on Friday. So for now we are just going to finish up with, where is it? I have it open over here. I have so many tabs open. Right, let's just find it, shall we? So, WJC, and then I go on to Mechanics A. Okay, so it's not that one. It's annoying, I feel like I had it open, but no. No, we've done that one. 2022. That's the one I haven't taught you yet. Yeah, this is it. Perfect. Right, so there's one of these vectors that's given by a vector straight line, which you do for part A. And then part B, there's a position vector given, and you have to show that it's moving at a constant speed. And then the very last part is show that the two vectors move perpendicular to each other. So have a go at that lunch, you've got about 10 minutes or so, and then we'll call it. Probably slightly under 10 minutes, to be honest.